So I found a new diagram. I want to explain it out a little better to my listeners. I know I get a little bit more views than I used to. Hopefully I can get people's money's worth out of these talks. Hi, Celeste. This diagram right here, I'll review this real quick. Basically, it says exoplanet formation. Assembly line of planets. The diagram illustrates how planets are assembled and sorted into two distinct size classes. Image credit, NASA Kepler Caltech by R. Hurt. Now, I can share this freely because, well, guess what? I give NASA money through my taxpayer dollars. What's up? Anyways, assembly line of planets. The diagram illustrates how planets are assembled. First, the rocky cores of planets are formed from smaller pieces. Then the gravity of the planets attracts the hydrogen and helium gas. Finally, the planets are baked by the starlight and lose some gas. At a certain mass threshold, planets retain the gas and become gaseous mini Neptunes. Below this threshold, the planets lose all their gas, becoming rocky super Earths. There's lots of problems with this, though. Where do I start? Okay, here we go. Rocky building blocks. Let's start with the very beginning. Rocky building blocks, where things are really small. Cobblestone-sized objects, pebbles, gas and dust. And I have here, how do you make rocks and minerals? Heat and pressure. All geology students know this. I learned this when I was going to University of Maryland when I took geology. It takes heat and pressure to form rocks and minerals. That's how diamonds are formed. That's how all rocks are formed. So to say there are pre-existing rocks in outer space begs the question, what object had the heat and immense pressure to form them? How did these rocks form? What's all this over here? There's no process here? They just appeared out of nothing? How do you form them? No answer. 2, says here, the rocky building blocks become rocky cores. So then the next step is this stuff self-assembles and becomes a rocky core. Anybody that's played billiards knows this is very strange reasoning. Inertial momentum just doesn't disappear when you want it to. It is a conserved quantity called conservation of momentum. That's why every single time you hit the cue ball against the numbered ones, no matter how fast you hit them, they will dissipate. Anybody that's played pool knows if you take the cue ball and you set it up and you rack the numbered balls and you hit the cue ball against the numbered balls dissipate. Everybody knows that. It's because of the conservation of momentum. The momentum of that cue ball is transferred to all those balls down the table, which then dissipate. And sometimes the cue ball just stays put around that area of the original triangle. So what they're telling you, or what the astronomers believe, I guess, is that these are all triangles that get hit by cue balls, which then self-assemble. You see how weird that sounds? You can't have rocks self-assemble in outer space without something causing the loss of inertial momentum, because momentum is conserved. There has to have been something much larger to clump these things together, or else they're not going to self-clump together. That doesn't make any sense, because anything that hits anything else will automatically just bounce off of itself. Some astronomers know this, but I guess it's just brushed under the rug. This is astronomers ignoring conservation of momentum. They know better. 3, adding gas. Well, ladies and gentlemen, a little known fact of nature is that gas will always move from a higher pressure to the lower pressure. It is gas diffusion. All engineering projects, tools, machinery, etc. operate off this basic principle. What they are saying here is that gas moves from the vacuum, which is the lowest pressure possible in nature, which is outer space, to an area of higher pressure. Gas doesn't do that. If it did, then your tires in your car would never go flat, basketballs would always self-inflate without a pump, and your vacuum cleaner would not work. Notice how they have this step right here where they say, oh, well, you're just going to add gas. Well, it's interesting to note that if you see gas there, the astronomers go, well, I see gas there that way, therefore it was added. They don't ever consider the physical implications of it. You can't take gas and add it to an area of higher pressure when the surrounding area around that object is vacuum. the gas isn't going to go from the vacuum to the area of higher pressure. It's going to go from the area of higher pressure to the area of lower pressure. Planets dissipate. They don't assemble from gas clumping or being attracted to a rocky object. It goes against basic gas diffusion. It's the basic gas laws. It's the same reason why, gosh, I don't like to talk about this, but that virus, whatever, when somebody sneezes, the particulates, those air parts, the water molecule particulates that have the virus on them, they dissipate through the room. So when you sneeze, that sneeze goes all over the room. That's why they're having people wear masks, because you can breathe that crap in. But I don't want to talk about that. But anyways, gas diffusion. It happens in nature all the time, everywhere. All engineering projects know this. All pneumatic tools operate off that basic principle. But in astronomy, for some reason, they say, well, gas doesn't diffuse. We can just ignore it. So they have the gas going from vacuum to an area of higher pressure without any mechanism. That's a doozy. They're gonna have a hard time convincing people that that's true. Number 4, heat. Heat flows from the hotter object to the colder naturally. This is basic thermodynamics called the second law of thermodynamics. Heat never flows in the opposite direction of its own accord. And what that means is they have planets as giant self-induced heat pumps. They have planets as objects that can pump heat into themselves from the vacuum without mechanism. So basically, they're self-induced heat pumps which pull the vacuum material from the vacuum onto itself, or the heat from the vacuum onto itself. Mind you, the vacuum is a hell of a lot colder than the object they're trying to form. It's very, very, very weird. There's no heat there. There's no heat in the vacuum. It's cold. The second law of thermodynamics states that heat goes from the hotter to the colder on its own accord. This is why planets, they cool down over time. They're when they're born really hot and bright, they cool down, and that heat escapes them. That's what happens in this theory I've been developing. But take a good look at this. How do we solve this issue? What do you guys notice is wrong? Well, it's very easy to solve it. They have it backwards. It starts from the larger objects over here, and then it goes to the right. So you have an object that starts really, really big and hot. It loses its heat, it loses its gas, then you end up with a little core, and that core smashes into other cores, making little bits and pieces. It's really that simple. Here's the diagram of the process. Once the object is really hot and bright, born from some really powerful electromagnetic event, it expands outwards, gets to its largest extent. That heat dissipates, the gas dissipates, and through this process in the interior, it forms that rocky core. So remember from the beginning when I said, well, how do you form these little rocks and minerals? Well, those are the end processes. What actually happens in the star is the interior is forming that giant rocky ball, and then the gas dissipates over time. See, the heat and pressure to form those rocks happened much, much earlier in the star's history. It happens up here. It happens way up here when it's really, really hot and really, really pressurized. That's where the rocks and minerals form. But over time, as that gas dissipates and leaves its little rocky ball left over, that object will smash up into other objects and create huge asteroid fields and, well, asteroids and comets and the gas and dust that we observe in telescopes. The gas and dust we observe in telescopes are the smashed up remains of completely disintegrated stars that have long since died. It just gets recycled back into outer space. And to answer the angular momentum issue, or not angular momentum issue, but the conservation of momentum issue, remember when I said that these objects won't self-assemble? Of course they won't self-assemble. Again, they have it backwards. The object that allows this stuff to clump together is the star itself. See, when a star is really big and has a huge gravitational field, it can cause that material to lose its inertial momentum. Because when an asteroid were, say, to hit the sun, it would obviously slow it down, and it would break it apart and then sort it out based off of the material's properties. And then, the pure iron nickel can go to the center, starting the core formation and all that stuff. But basically, what I mean is that the objects that can cause the loss of momentum to form a planet are the stars themselves, because that's what they do. They collect all the dust and gas from outer space, and they reform that planet in its interior. It's a big recycling process. It should sort of look like one of these numbers, or actually this way, this direction. But yeah, I think that basically sums it up. People at NASA, people working with Kepler Space Telescope, and the astronomers at Caltech, I think they should kind of review what it is they're trying to claim here, because thermodynamics is ignored, conservation of momentum is ignored, gas diffusion is ignored. It's like they're not even doing science. They're just looking out. They're saying, this is what I believe, to hell with everybody else. And then somehow that becomes the truth, which is really, really weird if you think about it. But looking at history, I guess that's a lot of the beliefs that we have started off that way. They just claim something to be true, and then it gets taught, and people just don't know any better, I guess. All right, y'all. Take it easy.